Imagine this, 13.8 billion years ago there was no time, no space, just an unimaginably tiny dot. Then, bang! That dot exploded and everything, yes, everything began. This is the Big Bang Theory. In just 5 minutes we're going to blow your mind with how our universe came to be. Let's go. So first things first, the Big Bang wasn't a normal explosion. It wasn't in space, it created space. Before the bang, there was no before. Time itself was born in that moment. The universe started as a singularity, a point so dense, so hot, it defies logic. And then, in a fraction of a second, it expanded, faster than the speed of light. Wild, right? In the first millionths of a second, the universe was a chaotic soup of particles, quarks, electrons, and photons. It was far too hot for atoms to form, with temperatures reaching unimaginable levels. This primordial state was a seething, energetic mix where particles constantly collided and interacted. But as the universe expanded, it began to cool down. Quarks started to combine, forming protons and neutrons. These protons and neutrons then came together to build the first atomic nuclei, marking the beginning of a more structured universe. By 380,000 years later, the universe had cooled enough for electrons to slow down and combine with these nuclei, forming the first atoms. Most of these atoms were hydrogen and helium. This significant event is known as recombination. Recombination was a pivotal moment because it allowed the universe to become transparent. For the first time, light could travel freely through space without being scattered by free electrons. That ancient light, which we can still observe today, is known as the cosmic microwave background. It provides us with a snapshot of the universe as it was just after recombination, offering invaluable insights into the early cosmos. As the universe continued to expand and cool, gravity began to pull together the gas clouds of hydrogen and helium, leading to the formation of the first stars and galaxies. These cosmic structures set the stage for the complex universe we observe today. Over millions of years, gravity went to work, clumping hydrogen into stars. These stars formed galaxies, creating the vast cosmic structures we observe today. Inside them, heavier elements like carbon and oxygen were born. Supernovae exploded, spreading these elements everywhere, the building blocks of planets and us. So yes, you are literally made of star stuff. Thanks, Big Bang. How do we know all this? Great question. The universe has left us a trail of clues and scientists have been piecing them together for decades. One of the key pieces of evidence is redshift. Galaxies are moving away from us, which means the universe is still expanding. This was first observed by Edwin Hubble and has been confirmed by numerous observations since. Another crucial piece is the cosmic microwave background, or CMB. That leftover radiation we mentioned? It's a snapshot of the infant universe, providing a wealth of information about its early conditions. This CMB is essentially the afterglow of the Big Bang, a faint light that has been traveling through space for over 13 billion years. Then there's the elemental makeup of the universe. The amounts of hydrogen and helium we observe match the predictions made by the Big Bang Theory, further supporting this model. When you put all these pieces together, it's like the universe has left us a giant cosmic breadcrumb trail, guiding us to understand its origins and evolution. But where's the universe heading? By studying these clues, scientists can also make predictions about the future, helping us understand not just where we came from, but where we are going. So, where are we headed? It's a question that has fascinated scientists and dreamers alike for centuries. The universe is still expanding, and might keep going forever. Imagine galaxies drifting further and further apart, creating more and more space. Some theories say we'll end in a big freeze where everything becomes so spread out that stars burn out and the universe turns cold and dark. Others predict a big crunch, where the universe's expansion reverses, pulling everything back into a dense, hot state. Or even a big rip, where the very fabric of space-time is torn apart, ripping galaxies, stars, and even atoms to shreds. But no matter the outcome, one thing's clear. Everything from your morning coffee to the most distant galaxy started in that one tiny spark. That spark was the Big Bang, the moment when everything we know burst into existence. The Big Bang didn't just happen out there, It happened to us. It's the reason we're here pondering the universe. Mind blown. If this blew your mind, smash that like button, subscribe for more 5-minute deep dives, and drop a mind-blown emoji in the comments if you made it to the end. Until next time, stay curious.